Hey y'all, today's objective is using equations to solve real world problems. All right, real world problems, because we live in the real world, not mathemagic land. Your goal is to write an equation that models the real world situation. So today is all about real world problems, and there's two parts to every question. You have to write an equation that represents that situation and then solve the equation to find the answer. But today's focus is all about learning how to decontextualize a word problem and write an equation. It's like those math practice standards that we've been going over, to decontextualize the word problem and write an equation that models that. Just a few tips that I think are helpful. Look for keywords in the word problem, and I'll teach you how to underline and look for keywords, and you already know what the keywords are. The second tip, look for the answer. So in every word problem, there's going to be the answer that's going to be on the other side of the equal sign. And that's like the best starting place to write an equation for a word problem, is to find what that answer is and to start there. And the other tip is use the inverse operation in the equation. So a lot of times when you read a word problem, you already know how to solve it. You know, oh, I need to add, or oh, I need to multiply, because you know how to solve it. If you know how to solve it, then you know how to write an equation, because you have to use the inverse to solve it. So let's just pretend you know that you need to add to get the answer. That means the equation must have subtraction in it, because the inverse of subtraction is addition. Just like let's pretend there's a word problem and you know that you need to divide to find the answer. Well, if you divide to find the answer, that must mean multiplication has to be in the equation. So I'm going to show you some of these tips to help you write an equation to represent a word problem. All right. Whoops, some of my board got erased. That's okay. So notice there's two parts, an A write and a B solve. I'm going to go through these word problems with you, and then there are a couple that you're going to try on your own. So example 1, Caleb measures his heart rate, so I'm abbreviating it, HR, at 123 beats per minute. So this is important, keywords. This is 55 beats per minute more than his resting heart rate. So before we go any farther, let's just talk about it. 123 beats per minute, and this is 55 beats per minute more than his resting heart rate. Write and solve an equation to find his resting heart rate. So that is what we're trying to find, his resting heart rate. We know something is 123. And we know that we're looking for his resting heart rate. So before we even start, think logically, is his resting heart rate going to be more or less than 123? I mean, don't tell me. Even if you tried to tell me, I couldn't hear you. But think about that. That should be a starting point. 123 beats per minute. Is his resting heart rate going to be more or less? The problem says this is 55 beats per minute more than his resting heart rate, which we're going to use that. So let's talk about how we would write an equation based on a word problem. We've already looked at some keywords. 123 beats per minute. This is 55 beats more than his resting heart rate. So does anyone see the answer? Like, what do you see as the answer? What information have I given you? And I've said this is this. That is a lot of what we want. And you know his heart rate is 123 beats per minute. So that is going to be only equal sign, because you know that it's 123 beats per minute. That is the answer to what is his heart rate. His heart rate is 123 beats per minute. This is 55 beats more than his resting heart rate. So let's talk about this word more. That means higher or lower? Higher. So higher translates to an addition problem. So then we know we're going to add 55 to something, but what are we going to add 55 to? If you don't know what it is, that's when you use a variable. You could use X, you could use R for heart rate, resting heart rate. I'm just going to use X because that's very generic. So this equation says X plus 55 equals 123. X represents his resting heart rate. So his resting heart rate plus 55 beats per minute equals 123, which is his heart rate right now. Caleb measures his heart rate at 123 beats per minute. To solve this equation, you would use the subtraction property of equality. You would subtract 55 on each side. And 123 minus 55, don't have a calculator, 8, let's see, 11 minus 5 is 68. Is that right? 68 plus 55, 13, carry 11, 12, yep. So x equals 68 beats per minute. And what did you say at the very beginning when I asked you? Is this resting heart rate going to be more or less than 123? Hopefully you said less. And our answer is less. And the very, very last thing you want to ask yourself is, does this make sense? Does it make sense that Caleb's resting heart rate is 68 beats per minute, while this other heart rate, maybe after he was exercising, was 123 beats per minute? Does that make sense? You always want to ask yourself, does my answer make sense? And then this problem, yes, it does make sense. Okay. Example 2. Your Blu-ray player costs $328 less than your TV. Your Blu-ray player costs $179. Write and solve an equation to find the cost of your TV. So first, let's talk about keywords. What are some keywords in this problem? Your Blu-ray player costs $328 less than your TV, and your Blu-ray costs $179. Write and solve an equation to find the cost of your TV. So we're looking for the cost of the TV. So before we begin, let's talk about what we know. We know that the Blu-ray player costs $179, and we know that the Blu-ray player costs this much money less than our TV. So which one's more, the Blu-ray player or the TV? What do you think? I'm not going to tell you. I want you to think. Reading the problem, the Blu-ray player costs $328 less than your TV. Your Blu-ray player costs $179. Find the cost of the TV. So right now in your mind, think about it. Which one's going to cost more, the TV or the Blu-ray player? And that should guide your problem. Do you see an answer? Do you see an answer in this problem? I see an answer. A definite. The Blu-ray player is $179. So that is how much is going to be on your equals, because that is your answer. That is your goal. That is your total. The Blu-ray player costs $179. Now let's talk about how you would solve this problem. To find the cost of the TV, what would you do if you know your Blu-ray player costs $179 and it's $328 less than your TV? What would you do to solve it? I think most of you are probably thinking you would add those two numbers to solve. And that's correct. That's how you would solve. So if you would use addition to solve it, then what operation has to be in your problem? Exactly, subtraction. So we know we're going to subtract something. And which one's going to be more? 320, the Blu-ray, the 328, or your TV? So your TV is what you're starting with. So I'm going to use that as X. When you take away the $328, that is how you get the price of your Blu-ray player. Let me go over that one more time. We know that the Blu-ray player costs $179 and it's $328. The Blu-ray player is less than the TV. That's how I got this less than. So the TV minus $328 gives us the Blu-ray player. To solve it, we have to undo subtraction with addition. And the cost of our TV, $507. And then let's talk about, does this make sense? Does it make sense that our TV costs $507? At the very beginning when I asked you what costs more, the TV or the Blu-ray player? The TV costs more. So this makes sense that your TV costs $507 and your Blu-ray player only costs $179. Maybe you have like a big flat screen or plasma TV. So we've gotten to a you try. I'm going to read the problem to you, and then I want you to try to set up the equation. Mary earns $9 per hour babysitting. How many hours must she work to earn $315? Mary earns $9 per hour babysitting. How many hours must she work to earn $315? I want you to pause the video, work it out on your own, and then when you're ready to hear my explanation, resume the video. So first I like to look for keywords, and I think it's important that she earns $9 an hour. How many hours, that tells me what we're looking for, to earn $315. I'll drop my marker. And my total, what is my total? What is my goal that we're looking for? And our goal is $315. And how am I going to get that? Well, Mary earns $9 per hour. How many hours does she need to work? Now, if you don't know about this little word per, that little word per typically means multiply. So for this problem, I kind of think about it backwards. How would I solve this? Well, you know what I would do to solve it, to find out how many hours, is I would say 315 divided by 9. So if I'm using division to solve it, then what needs to be in my equation? Multiplication. So 9x, or you could use h if you wanted to use hours. So my equation would read 9x equals 315. To solve it, I would divide both sides by 9. And that's when I come over here, 9 will go into 31, what was it? 3 times 9 is 27. So 35 hours that Mary needs to work in order to reach her goal. 35 hours that she needs to work to reach her goal of $315. Does this make sense? Well, she makes $9 an hour, and if she works 35 hours, then she would earn $315 total. All right. Example 4. Now this one is a two-step example, a two-step equation. So let me show you how to work a two-step equation. Devon's phone company charges $15 each month for service plus 10 cents per text message. I'm sure most of y'all have unlimited texting, but Devon does not. Devon, tell your mom you want unlimited. If Devon's bill for October was $90, so just the month of October, how many texts did he send? We are looking for how many texts Devon sent for just 1 month of October. So again, I've underlined keywords. We've noticed a plus right here. So let's talk about how to write our equation. First thing we want to look for is, what is your answer? What is your total? What is your goal? What is your end result? So in this problem, what was our final answer? What was that definite amount we knew? That his bill was $90. There are two parts to a phone bill for Devon's phone bill. Each month he has to pay how much? $15. Does that $15 ever change? If it's October, how much is it? 15. If it's November, it is 15. If it's December, it's 15. So that $15 doesn't ever change. The 10 cents per text, is that going to be the same each month? Does he always send the same amount of text each month? The answer is probably no. So the 10 cents per text amount might change. And then we have a plus, so we know we're going to add the 2. For the month of October, that's just 1 month. So how many times are we going to put in 15? Just 1 time. So 15 is just in there. There's no variable. That's what we call a constant. If there's no other variable, it's just 115 because it's just 1 month of October. Now the 10 cents per text, remember we talked about this little word per, means times. Do you know, Devon, how many texts did you send? You're not sure? I'm not sure. So let's talk about, what do we put? 10 cents per text, meaning X. The variable, we don't know how many texts he sent. It could change. And that's what we're trying to find out. It says how many texts. That's what we're trying to find out. So that is our variable. Here's our two-step equation. 15 plus 10 cents times X equals 90. We go into the solving process. We take 15 away from both sides. And we get 0.10, X equals 75. We divide both sides by 0.10. And X equals 750 text messages. Whew, 750 texts. I bet your fingers are sore after that. 750 texts in 1 month. To me, that seems a bit ridiculous, but I'm not a teenager, so does this make sense? Y'all tell me, does 750 texts even make sense? I just can't even fathom sending 750 texts. But I guess it's true. I got this. All right. So here's a you try, number 5. I'm going to read you the problem. I want you to pause the video, write the problem, and see if you can solve it. Jessica wants to save $900 for a trip. She plans to save $45 each week and already has $180 saved. How many weeks does Jessica need to save to reach $900? A, write an equation. B, solve your equation. And then when you get your answer, always ask, does this make sense? We are trying to find out how many weeks. So your answer is not money, and your answer needs to be weeks. So it has to make sense. It has to make sense. You can't have like 0.5 of a week. Well, I mean, I guess you could. That'd be half a week. But how many weeks does Jessica need to reach $900? So does this make sense? So I want you to work this one out, and then we will go over it tomorrow in class.